Okay, good afternoon, everyone. I hope I'm clearly audible. So welcome to the first session of Embedded Machine Learning for Edge Computing. Let's get things started. So today the purpose is to give you an overview of what we will cover throughout the course. So to do that, we'll have a couple of sessions for today. We'll first introduce to you what we do as a department, as the Department of Electronic and Telecom Engineering, and how offering these courses fit into our long-term goals as the department and also as a nation. Then we'll have a keynote speech on machine learning in general. And then as the last session for today, we'll look at what we will cover for the coming 8 weeks. So we will have 16 days of classes. What will happen in those days, we will let you know. And evaluation criteria, what you have to do to complete the course successfully, and some other course-related logistics as well. So let's get started with that agenda for now. We expect this whole thing to take about 2 to 3 hours. Of course, you can ask questions as well and clarify any doubts that you have. To get things going, I would like to cordially invite the head of the department of the Electronics and Telecommunications department at the University of Moratuwa, Dr. Ranga Rodrigo, to welcome all of you. Dr. Ranga received his bachelor's from the same department and then his PhD from the University of Western Ontario in Canada. So he specializes in computer vision, and he's the ideal person to talk to you in the beginning and to welcome all of you to the session today. Dr. Ranga, over to you. Okay, Dr. Ranga just dropped me a message saying the mic and video is disabled. Let's see.
Okay, now it's fine. Thank you very much, Dr. Subodha, for the kind introduction. May I be able to share the screen also?
Yes, sir, please.
Yeah. Yes, thank you everyone for joining today. I warmly welcome you for this course on machine learning for embedded systems. I think I'm very excited that many people have joined the course. I welcome Dr. Subodha Charles also, who is in charge of the course. Actually, Dr. Charles has earned expertise in embedded systems, learning in embedded systems, and cyber security in embedded systems. He is a very appropriate person in that context to be in charge of this course and oversee the course. And we have other teachers also joining. Mr. Kipit Vikram Singh is joining from Vancouver, Canada. I think it's early in the morning for him. Thank you very much for joining. Welcome, each one of you. So I will briefly talk about our department and briefly talk about machine learning as I see it. And then in the keynote speech, I think you will be able to get a very strong understanding about what is actually there in machine learning and so on. Okay, so electronics department is a department in University of Moratuwa. So I am the head of the department there. So we see a university as a place where intelligent people gather to share knowledge, to preserve knowledge, and to create knowledge. So as you can see, this session that we have right now is the way we share our knowledge with you. So we have built a knowledge base on machine learning, applying machine learning in other tasks like computer vision, self-driving, and so on. And we know how to run them on these tiny devices called embedded systems, which are so-called resource constrained. And we want to share that knowledge with you. So this is the purpose of this. And then we preserve knowledge through our publications and so on, and we create knowledge through our research. So that's the purpose of a university. And we do this, and when we do this, we have actually for our undergraduate program, we take 16 for the biomedical engineering and 100 for the electronic and telecom engineering program. We have about 23 staff members, about more than 20 are PhD holders. And we have a nice building, and we have labs and advanced software tools. In regard to graduate degree programs, we have two taught MSc programs, MSc in Telecom, MSc in Electronic and Automation, and of course, 2-year research degree programs called MPhils, and then 3 or more years for PhD degree programs. So we have had a great successes in the past. So one of them is the winning of the IEEE Extreme Programming Competition in 2009, 700 teams, 40 countries. It was a great achievement. And since then, many achievements in last year, 2021 World Champions in Signal Processing Cup, ICS Challenge 2021 Champions. And then we have been able to reach top conferences in this area called computer vision and pattern recognition. Pattern recognition is the engineering term for machine learning. So in robotics also we have achieved things. So you can see last year IES CMD student robotic demonstration was won by these students. So these techniques can be applied in robotics, and we know how to do that, and you will get a brief flavor of that also in the course. So some success stories of our past students. So there's a device called FPGA. Maybe you have heard of that. Field programmable gate array. Slightly more complicated things can be done than in a microcontroller in these devices. And some of our students won the grand final silver award. It's a world event sponsored by Intel, and they won the Japan and Asia Pacific Gold Award also. So some of the students just after graduation, they went to Harvard University to carry on some of their work, microscope work based on some processing done in these kind of devices and advanced processors also. So you can see one of the students, the next keynote speaker also knows this student, Mohammed Affam. He joined Meta or Facebook, and you can see the picture with one of the fathers of machine learning or deep learning called Jan LeCun from New York University and Meta. So great publications in great places. So you can see we are well equipped in regard to our knowledge to deliver you this program. So pictures of some of our staff members, you can see they have obtained graduate degrees from different places in the world. So Dr. Charles graduated from Florida University in the US. So that's where he obtained his expertise. Actually, his professor also gave a talk to us. So I learned that he has very unique expertise to be able to deliver this course. Yes. So these are some of the places where our staff members have obtained their higher degrees, mainly from the North Americas, and then Europe, then Australia and Japan, and so on. Okay, so some of these exciting projects that our students have done, you see, like when you see these things, you see only the outcome. Okay, so when the robot is jumping up and down, some algorithm is running inside the device that is on the robot. You know that, right? That has been programmed. And this, although now it looks like magic, the robot is jumping and this robot is climbing the rough terrain. You see that it looks like magic, but still, these are carefully crafted algorithms based on experience. So when we are able to learn from experience, learn from data that we have, we call it machine learning. So when we have them running on little devices on robots or for other appliances or microcontrollers, as you know, we call it machine learning in embedded devices. So this is the purpose of that course. So you can see beautiful things can be done this. So these applications took time to develop, this carom playing robot, terrain climbing robot, and so on. But these things can be done. So we will give you the knowledge components required to program these devices. So building a complex system like this needs your time and innovation, as you all know. So some of the projects that we have done, actually these projects, these are, you can see, for autonomous driving. They do not actually run on tiny devices. They need Jetson, at least slightly complicated devices. In the course, we will briefly talk about those devices also. And then if you want to develop an intelligent camera like this, then inside the camera, we have to do this machine learning kind of programming. If you want to detect things using the camera and so on, for that, we need FPGA like devices, slightly more complicated than microcontroller. So you can see in this one, the processing is done on actually the servers. It is a multi-robot collaboration approach. Here you can see the aircrafts that the department has developed under Professor Rohan Munisinghe. So the UAV work. These aircrafts also run these processes. By collecting data later on, we can learn from the data that the aircraft collects. So you can see the beautiful things that can be done with the knowledge that you are going to gain in this program. So do not expect to develop an aircraft or a multi-robot system after the course. That remains to be done by a lot of investigation and work by you. But the key theoretical knowledge components and the hands-on components will be given in the course. So let's briefly look at what machine learning and deep learning is. So I briefly talked to you about what machine learning means. Actually, they look like magic, but actually you learn from the past experience that you had. Okay? So when you think about deep learning, what we do is you stack large number of layers on top of each other, multiple layers. So these are called neural network layers. So because there are a large number of layers, we call it deep. So that's why this deep learning term has been given to those kind of networks. Now these things came to be possible because of this reason. So earlier people were programming things on using desktop processors like Intel processors. And then suddenly the computational power increased due to the so-called graphics cards. Maybe you have heard of these cards like NVIDIA RTX 3090. This is an important graphics card. And then this is a very expensive graphics card, A100. And then on the cloud also, service providers like Google, Amazon, and so on, they provide computational ability to run these massive parallel computations. So unlike a regular processor on a computer, these parallel devices that can run many parallel simple computations accelerated the deep learning area. Also, on the other hand, people realize that these are not only work that can be done in university laboratories, but these are very much useful for the industry. That's why you also have gathered in numbers to learn how to do that in the industry. So there is an industry applicability, and the computational power made it useful to do large systems. And then people realized, okay, the running them on large computers is good, but that's not good enough. So therefore, people try to see how can you represent them in a proper way so that they can be transferred onto embedded devices like what you're going to learn in this course. This paradigm opened up many other devices, many other, like maybe a washing machine, maybe some other voice recognizing system, maybe a people counting system. All these devices to have machine learning inside them. So that's how the machine learning paradigm has evolved. Of course, this large scale computing paradigm is there. So some of the things cannot be done in universities now. They are being done by large techies like Meta and Google. So actually you will be hearing from a senior scientist in Google very soon. So it's a very exciting world. But where does machine learning fit in the general area of artificial intelligence? I want to talk about that also. What is artificial intelligence? What is machine learning? What are neural networks, and what is deep learning? So this diagram represents that. So artificial intelligence is an overarching set of algorithms. So even simple algorithms that learn from experience amount to machine learning. And within that, there are some techniques called machine learning techniques. So neural networks is one of the machine learning techniques, and deep networks, as I told you, when you stack large number of neural network layers, becomes the most used machine learning paradigm right now. So before this machine learning paradigm came into, before this deep learning paradigm came into being, people had so-called feature extractors. That means if you think about an image like that, we represent image with a few numbers, not a few, maybe 4096 numbers. So each image is represented by 4096 numbers. With these numbers, we do something and identify, oh, this image is a cat, this image is a dog, like that. So you don't have to work with the whole image at once, but you can work with those 4096 numbers to identify whether the image represents a cat or a dog or any other object, a known object. Now, so if the image is a cat and we call it a dog, that means there is a loss occurring, right? So we use this loss as a signal to train this classifier so that it does not make that many errors. So to reduce errors, we minimize a so-called loss. So this is the so-called training paradigm in machine learning. But it does not mean when you transfer them onto embedded systems, embedded devices, we do the training also in the embedded system. So we can do the training on a computer and then learn this system and transfer those weights, so-called weights, onto the embedded system so that the actual runtime or the inference time can be done on the embedded system to get the actual images recognized or to do the actual accounting or do some actual voice recognition. So when deep learning came into being, this so-called feature extractor and the classifier combined together. So this is one neural network. So you train the whole thing with this signal that we get from the mistakes that the network does. Now, when you think about how we learn also, it is like that, right? So sometimes we ask a child to come and say, show him a picture and ask, what is this animal? The child would say, it's a cat. Then we would say, no, Buddha, it's not a cat, it's a dog. Then the child would learn from that uh, signal that we gave to the child. If the child says, looks at a dog and says dog, we will say, oh, very good, it is a dog. So this is how machine learning also works. This is how deep learning also works in many aspects, but there are some other things which work without labels or without these kind of signals, but we will not touch about those things right now. So this is the paradigm. But when we look at these neural networks and see what the neural network learned. So I said that this classifier worked on 4096 numbers. If you take those 4096 numbers and see them as pictures, people were very excited to find out that the number that represented the car, the set of numbers that represented the car actually looked like the car when you looked at this as an image. So you see these networks learned meaningful things. So sometimes people like to say in deep learning, we do not know what is going inside the network. It is not that much true. So there is some truth in that, but it's not entirely true. We are able to understand what goes within these networks. So that's the general learning paradigm. I'm sure that the other speakers, especially the keynote speaker, will give a much broader and much more exciting overview of this to you. So what is the purpose of this course? So we have been doing microcontroller-based system design courses like this. And then we realized, oh my goodness, we have a lot of expertise in machine learning and computer vision. And we know how to implement them in these little devices. And why don't we offer a slightly more advanced course in embedded machine learning for edge computing? So that's how this course resulted. Many students asked us to do that. And also the staff members who taught in the course, like Mr. Kitmin Wickramasinghe, said that, okay, we must teach this course so that it is beneficial for all the Sri Lankans to do some useful work and make their careers better, make their finances better, and so on. So the purpose of this course is to show you how to implement these machine learning algorithms in resource-constrained embedded devices. So yeah, we are very excited that you are here with us. So I invite you and suggest you that you very conscientiously, with a lot of interest, take part in all the 16 classes so that you can get the full knowledge. Do these exercises. When you do them only, you learn. Then you will have a lot more questions also. Please do not hesitate to ask those questions whenever they arise. So even after the class, ask them, get them clarified. So Dr. Charles has lined up a very good panel of lecturers who have actually industry experience to teach you the value of this and the actual hands-on things about machine learning in embedded systems. So once again, we are a university where intelligent people have gathered to share knowledge, preserve knowledge, and create. We are sharing our knowledge right now with you. So you are most welcome to contact me with email ranga@uom.lk, see our websites, Facebook and YouTube. Thank you very much. I wish you all the best for this course, and I hand over the controls back to Dr. Subodha Charles. Thank you very much.
Thank you, Dr. Ranga, for that insightful presentation and for the welcome. I will post recording now for a while. Okay, so we spent about 1.5 hours. I think that gave you a good understanding of what we are trying to do as a department and also what machine learning is. That was a quite insightful keynote by Sadeep. So for the remaining 1 hour or so, I will walk you through the course introduction, what we will do in the remaining 8 weeks. Right. So a quick introduction about myself. My name is Subodha Charles, and I work as the course coordinator for this particular project. I graduated from ENTC and got my PhD from the University of Florida. I work mainly in embedded system security. And prior to joining ENTC, I worked at Intel and Zone 24/7 in Sri Lanka as well. Throughout the session, if you have any questions, this link was sent by Kitmin as well earlier in the slides, in the chat, in the Zoom chat. So feel free to ask any questions if you have at any point. I'll keep my video turned off to make sure that you can hear me properly and that you can see the slides without any interruptions, because connectivity, you never know, it goes up and down. So I'll keep it off for now. So any questions, send that on Slido, or you can use the Zoom chat as well. Either way is fine. Okay, so we are talking about machine learning in embedded systems. So for that, there are 2 parts. One, machine learning, and the other one is embedded systems. So we talked about machine learning in detail for the last hour or so. Let me quickly tell you what embedded systems are, and then we'll touch upon the motivation of this course as well. So you can see embedded systems everywhere. We already talked about self-driving cars, and there are systems, embedded systems inside a car that do various different things. You take medical, you take entertainment, home automation, anywhere you look, pretty much there is an application of embedded systems. And all of you, I'm 100% confident, without a doubt, you have used an embedded system at one point in your life. Of course, you have a mobile phone. That is another embedded system that you can take as an example. So these embedded systems, somebody had to develop these things. It did not just come about. When you think about developing embedded systems, we can categorize this huge domain into different sub areas. And even these sub areas are huge, don't get me wrong. You can break it down into hardware, mainly developing the brain behind these embedded systems, and then software. That is, you program these hardware devices. Then you also need to communicate with each other. Otherwise, you doing a job as an embedded system, that particular system doing one job is not going to be not very efficient. It's not a distributed system. So when we talk about things like Internet of Things, we have different sensor nodes communicating with each other and then doing some job that is assigned to that network of sensors. And the last piece of the puzzle is that this is not really relevant to hardware, computer architecture or software. We have to make them look better as well. So this is a design aspect to that. So out of these areas, in this course, what we will do is we will focus on this part, mainly programming and the software side of things, because that is where machine learning comes into the picture. As Dr. Sadeep mentioned, there are many players in the global market right now working in this area in embedded systems and in embedded machine learning. We already went through some of these companies, so I'll not spend too much time talking about this. So what about the future? Where are we planning to go? So if you Google for the future of embedded AI or embedded machine learning, you will find a lot of statistics. And here are some of them. A review by Gartner, that is a leading research organization, they say that about 10% of the data was processed at the edge, at the embedded devices in 2018, only 10%. But by 2025, about 75% of all the processing will happen at the edge, which means there is no cloud connectivity. Even if there is cloud connectivity, the processing will happen at the edge. Then another statistic, that the global market for embedded AI is expected to grow at a rapid rate, and the market is expected to reach by 2026 about $38 billion. So that's a huge market that we are looking at. So where are we as Sri Lanka? Where are we right now? So I extracted this data from the EDB website, the Export Development Board website, and they categorize electrical and electronics together. They of course don't categorize embedded systems and machine learning. They categorize it as electrical and electronic. You can see our market share is very small, right? So this is one of the motivations. If we are to move from a service-based economy to a product-based economy, as you can see in most of the newly industrialized countries, the gap between the product exports and service exports is huge. You see 17,274. This $1 billion. It's 357.54. Where do we stand? It's 11 versus 8.4. So it's a very marginal difference. So we need more and more people into the product sectors, and we believe that embedded systems can play a crucial role in that, where we can contribute, basically electronics and semiconductor industry in general, where we can contribute to the global market and increase our revenue as well, the exports as a country. So now that's the motivation. I'll give you a little bit more details about embedded systems, and then we will talk about the connection between embedded systems and machine learning, and then go to the course outline. So I'm pretty sure that you have used a computer, a laptop, or a desktop in your life. So that is what we typically call to as general purpose computing. What's the difference between general purpose and embedded systems? So to make the differentiation, we can have a brief look at this table over here. So when you think of a personal computer, it is built to run a lot of applications. You can dynamically add applications. You can remove applications. So when you install a software, that is what you do. And you uninstall a software maybe when you don't need it. So you dynamically add and remove applications. So this is possible in a general purpose computer because you have a lot of resources. You have a lot of computing power. You talk about i5, i7, this many gigahertz of processor. And then you have a lot of memory as well. You have gigabytes of memory or even terabytes. Nowadays, you have SSDs. So everything is contributing to a resource-heavy structure. That is what we typically refer to as general purpose computing. But the main thing about embedded systems is that you don't have a lot of resources. You have lightweight infrastructure. Your processor can be less, the speed can be less, you don't have a lot of memory, you cannot plug in every peripheral device. So you are less resourceful when it comes to embedded systems. So this is the challenge. When we look at machine learning, in Dr. Sadi's presentation as well, we saw that we can run very computationally heavy workloads in general purpose, in the cloud, in those architectures. But now when you come to embedded systems, you need to optimize so that you can run these applications in that resource-constrained environments as well. When you zoom into an embedded system, typically you can see a processor with some internal memory. You have some power source to power it up, and you can plug in external hardware as well. Now, this processor, if it just sits there, it's not going to do anything. So you need to program it. So typically you connect an external programmer, and then you program this embedded processor. This is done through a host machine. For example, if you have played around with an Arduino, you know that you plug the Arduino in, you do the coding on your computer, and you upload the program. That is what I have shown here. So the development happens at the host machine through the programmer. You send the data and the program to the processor, and then it starts executing. So nowadays, this programmer or the debugger, it will be on board as well. That means on the development board itself, you don't have to get anything extra. It is already integrated. So if I transform this block diagram into something that you have seen, here is an example from a Texas Instruments development platform, the simple link Launchpad. You can see these subcomponents that we just talked about, the processor, the power system, and the onboard programmer and the debugger. You connect that to the host platform, which is your computer, you do the coding, and then you upload that to the system, and you get things done. Now, when you think of this processor over here, and you zoom into the processor, it can look something like this. So it's a very basic block diagram. One solution for this processor would be a microcontroller, right? So you might have heard this word microcontrollers, of course. These microcontrollers and microprocessors, these are two different words. They are not the same. Typically, a microprocessor has more resources, more computing power. A microcontroller, on the other hand, it does not have the same amount of resources. You can see in a microcontroller, we have some memory registers. We have ALU, which takes care of all the computing. You have the debug system as well to see if something goes wrong. And this processing unit, it connects to the memory, some input-output ports, and some other peripherals as well through this bus. So the bus takes care of all the communications. In addition to that, you have the clock that synchronizes what needs to be synchronized. And then you have a power management unit as well. So this is a typical view of when you zoom into a microcontroller, this is what you will see. Now let's overlap our block diagram with one particular microcontroller. This is in the development board that I just showed you. You can see the overlap, right? You can see the CPU components and a large number of peripherals that support the computations. So in this course, this is what we are dealing with. We are dealing with microcontrollers. We want you to know and learn how to deploy machine learning applications in these microcontrollers. So these microcontrollers are used in a variety of applications, like we saw earlier. If you take like a car, there can be many subcomponents, and things can become very complex very fast. So to understand embedded systems, we typically look at a simplified version of this complex system. And the way we simplify things is using this simplified block diagram. So in an embedded system, a typical block diagram looks like this. You have the computing resources. This is what we talked about, the microcontrollers. In addition to that, you can interface sensors and actuators. The sensors will sense the environment. We will do some computations, and then we will take some actions through the actuators, or maybe you display something. And to facilitate this interfacing, we have analog to digital converters and digital to analog converters, because sometimes the sensors give an analog reading and the computers are capable of processing digital data. So we need to have this conversion over here, right? So this is an embedded system, and inside embedded systems, as the brain, you will have microcontrollers or microprocessors. And our job here in this course is to teach you how to deploy machine learning in these embedded systems. So now you have an idea about what embedded systems are, and in the keynote, you got to know what machine learning is. Let's try to combine the two. I will use this video for that. That shows you what embedded AI is. Just a very brief overview of what that is. Let's get to that real quickly. I will share the screen, including audio, so that you can hear as well. It's a 2-minute video, won't take too much time. Right, let me know if you cannot hear audio or you cannot see the screen. I think I'm sharing the correct screen. Let's play it.
Want to see something cool? Alexa, what's the weather outside in Denver?
Right now in Denver, Colorado, it's 31 degrees Fahrenheit with cloudy skies. Today's forecast has snow flurries, with a high of 35 degrees and a low of 16 degrees.
Okay. I know the Amazon Echo has been around for a few years, so this might not seem so interesting, but voice is still the new frontier in the world of computer interfaces, and it's all made possible with embedded machine learning. When we think of machine learning, we usually think of powerful servers crunching tons of data in order to do things like filter out spam emails, recommend movies for us to watch, and predict traffic patterns during our commute. But not all machine learning can be done in the cloud. Sometimes you have to compute things locally to get the job done, and this is the world of edge AI. For example, what happens if a self-driving car loses its internet connection? It needs to be self-reliant enough to obey traffic laws and not crash into anything. That means putting a lot of processing power in those vehicles in order to capture data from the various cameras and different sensors and then use it to make split-second driving decisions. For years, machine learning research has been focused on large servers and desktops, even though self-driving cars require powerful computers. Simple object detection in a picture requires thousands or millions of operations in a complicated neural network. Researchers in the last few years have made huge efficiency gains in being able to run machine learning algorithms on tiny microcontrollers. And there are some tasks that can be accomplished with smaller neural networks or simpler machine learning models. That leads us to embedded machine learning, or TinyML. Running machine learning tasks on a single board computer isn't really anything new, but doing them on a microcontroller opens up a new world of possibilities. Because microcontrollers are cheap and power efficient, we can begin to make a whole new generation of AI-powered electronics. This Echo is one great example. It uses embedded machine learning to listen for the Alexa keyword and then streams everything after that to a server, which then processes your request using more complicated machine learning algorithms.
That gave you an idea where we are going to go through this course, right? Let me share the slides again and remove the audio from the computer. Right? I hope you can see the slides again. Let me know if you cannot. That gave you a very brief overview of how we are combining machine learning and embedded systems. So in the video, you saw in the beginning that machine learning typically uses a cloud infrastructure that crunches tons of data. But when it comes to embedded systems, we have another set of challenges. In addition to what you already have in machine learning, you have another set of challenges to overcome. And those are, we have limited computing resources. I mentioned this already. We need to consume low power because some of these edge devices, it can be possible that they run on batteries. So you cannot have unlimited power at your disposal. And also, you need to do real-time processing. We took the example of self-driving cars. So if you need to make a turn and you make that turn few seconds later, then that can lead to a fatal incident. So we need real-time processing for these. Throughout the course, we will see how to develop machine learning models and how to deploy them on embedded systems while keeping these challenges in mind, while making sure we use less resources, we use less power, and we do real-time computations. So with that, let's look at what we will cover throughout the course. So our main focus is to take the machine learning models that are deployable in the cloud, develop the models, and then transfer them into or convert them into models that can run on these embedded devices. And this domain, if you were paying careful attention to the video mentioned this name as well. This domain we call TinyML. TinyML is the applied machine learning field that brings the potential of machine learning to low-cost, power-constrained, and low performance edge devices such as embedded systems. So it's a whole new area that is upcoming, that is quite hot right now, and that is the domain that we want to go into through this course. It sits in the intersection of machine learning, embedded systems, and applications. And the capabilities of these small form factor devices, it makes it possible to go through this full machine learning workflow. As you can see, all the way starting from collecting data, pre-processing, designing, training, and then making inferences. So this entire flow is possible on an edge device. When you look at the resources available to us today to achieve these things, we have about tens of millions of general purpose computers or cloud-based resources. And we have about 4 billion handheld devices and more than 250 billion edge devices. So these are the resources that we have right now. And for you as a person to learn how to work on these things, you have limited learning materials. So when you compare the number of devices from different categories with number of courses, the courses like this, the one that we are teaching right now, to learn general machine learning, you have many courses. You go on the internet, you will find many courses. To learn mobile ML, mobile machine learning, you have a handful number of courses. But to learn tiny machine learning, that's tiny ML, the things that we are talking about in this course, you have a very few. So this was another motivation for us when developing this course, right? So our goal is to deploy this tiny machine learning knowledge to solve real world problems and teach you how to do that, right? The inspiration for the course projects. So that is an important thing that I wanted to highlight. All the materials that we teach in this course will be taught through projects. So it's not like we are going to cover theory all the time. We will give you the necessary background. You will learn within the context of these projects so that you can get hands-on experience at the same time. We draw your attention to some of the cutting-edge features that you see in modern-day mobile and smart devices. The first one, as you can see in this animation, it is when if you have an iPhone, you know that you unlock your device by looking at it. So it detects you as a person and it detects that you are the owner of this device. So that is, it's a bit more advanced, but in this course, we will talk about person detection. And the other application that we will look at is this. I think you can figure out what this is by looking at this animation. We call Hey Siri to your iPhone, and then the automated assistant will come up and ask you, what can I help you with, right? Similarly, if you're using Android, there is Google Assistant. And in the video that I showed you earlier, we saw Alexa, right? So here we call it wake word detection. What we mean by a wake word is this word that says, Hey Siri, that wakes the assistant up. That is a wake word. And in the Google Assistant, it's Hello Google, right? So can we detect the wake word? Can we develop a model that allows us to detect these wake words? That is our second problem. The third one is gesture recognition. So you might have seen this if you have an Apple Watch, a smart watch. When you wear the watch and you make different gestures, the watch is capable of detecting these gestures. Why does it matter? Well, of course, you can use it to perform different tasks. You can customize it and then use it to perform various different things through your smartwatch. So these are our three main focus areas: person detection, wake word detection, and gesture recognition. Throughout the course, we will deliver the material in line with these three concepts. The gesture recognition part will be given to you as an assignment. Okay, so don't worry. We will not just give you the assignment and ask you to work on that. No, we will teach you how to do the assignment, but we will not give you the solution, of course, that you have to come up with on your own. And the other two concepts, the wake word detection and person detection, we will develop everything with you. So this will not be an assignment, these two projects. We will teach you from the basics. We'll write code with you. We will develop the entire machine learning pipeline with you. We will tell you how to deploy that on an embedded device. That will be the focus of the course, in addition to the assignment that I just mentioned. For the wake word detection problem, we have actually simplified this so that even a beginner can get started rather than going into the complex domain of how Siri or Google Assistant works. Here, what we're trying to do is we will detect two words. One word is yes, and the other word is no. You can see here when we deploy this, so these are images from our deployment. When you say yes, the green light comes up. When you say no, the red light comes up. Okay, so that is what the model will do. You say anything else, nothing happens, right? So now the wake word is yes and no. The system will detect and light the correct bulb or the color to indicate that the system understood the word that you just said. The second project, person detection, you can see in this animation over here, this is the camera on the left-hand side. The camera is now open. Now it is closed. When the camera is open, we have a person in front of the camera and the green light goes off. When the camera is covered, the person cannot be seen So the red light comes up. That is your second project. Let me give you a more detailed breakdown of what we will do through the projects. For the wake word case, we will create a wake word detection model with TensorFlow. Dr. Sadeep already mentioned about this. That's a very popular framework to develop machine learning applications. We will teach you how to step-by-step create the wake word detection model, and we will use a pre-compiled data set to evaluate the model. We first build it, and then we will convert that developed model to a microcontroller compatible format. Then to deploy this in this microcontroller, we need to get the hardware and software working together, because you're saying something and that has to be captured through a microphone. Right? So we talk about how audio can be retrieved through these interfaces, and we infuse software and hardware. We teach you how to feed the audio data into the model. You can also visualize the difference between the yes word and the no word when you look at the spectrum of the audio. So we'll talk about these as well. That is project number 1. Project number 2, the person detection one, will follow a similar structure. We give you the step-by-step process of building this person detection model, and then we evaluate that with a publicly available dataset. And similar to the previous project, we convert it to a the microcontroller compatible platform, and then we deploy. So here we use a camera that will allow you to get an image and detect whether there is a person in that image. Right? And we can also visualize the outputs, how the decision happens, whether a person is there or not. Right? So I hope you got an idea about the 2 projects. And the third one, the gesture recognition one, will be given to you as an assignment, and the required background will be given to you through the lectures. So to do these 2 projects, of course, we need hardware. Otherwise, you cannot capture audio, you cannot capture the image. For that, this is the hardware platform that we are going to use. It's called the Tiny Machine Learning Kit. And inside this Tiny Machine Learning Kit, you can see there is a development board, and then you have the camera. You have some other connectors as well. This development board over here, it fits perfectly to our requirements. You can see it has an inbuilt microphone in addition to the processor. It has an IEMU device. It has temperature and humidity sensors, and you can program it through USB. We will not be using the temperature and humidity sensor in our instance, but the capability is there if you would like to use that for a different project. So this is the hardware platform that we will be using throughout the course. These 2 projects and the assignment, the gesture recognition one, we have centered the entire learning experience around these 3 concepts, right? So this is what we call like inverted. So we thought of calling this series of courses inverted courses, because we start with the end goal first and then work backwards to teach you how to develop those things, right? In traditional learning, what happens is we teach you the theories, and then at the end, we tell you what the applications are. But in this case, we give you the goal, you know what you will achieve at the end of the course, and we give you the necessary ingredients to achieve that goal. With that in mind, we have structured the course to make sure that you are able to achieve that goal at the end of the 16 days. We'll have 8 weeks of classes, right? So you can see the schedule, day 1, day 2, day 3. The first 5 days, today is day 1, starting day 2 until day 5, we will give you the basics of machine learning. So we do not assume any prior experience of machine learning from you. Then we'll take a small break. On 15th, we will not have classes. Then day 6 onwards, we will look at deploying machine learning on embedded devices. Let me give you some more details related to those. This is the second half of the course, the second 8 days from day 9 to day 16. Let me elaborate on these content a little bit more before I wrap up. So you are here today in day 1. Our purpose today is to give you an idea of machine learning, which we did through the keynote, and introduce the course to you. So this particular day, that is day 1, this session, this is free for everyone. Anybody can join. You don't have to pay to join this day number 1. And our purpose is to tell you what you are going to do so that you can learn the goals and what you will learn through the course. And then you can make a decision yourself whether you want to continue from day 2 onwards or not. And from day 2 onwards, we'll start our more technical discussion. Right? So we'll first start by giving an intuitive introduction to machine learning. The keynote covered most of it. We'll fill the gaps and we'll tell you what the difference between traditional programming and machine learning. And then we'll differentiate AI, machine learning, deep learning. We'll talk about the differences. We'll give an overview of deep learning. And on that day, we will also walk you through a Google Colab notebook. So it's a cloud-based platform that allows you to code and visualize machine learning algorithms. We'll walk you through some state-of-the-art models like CLIP and tell you how to use these tools in the beginning. Then in day 3, we will introduce machine learning with some more hands-on experience. So in day 2, you got the basics. Now let's start applying these basics from day 3 onwards. Right? So we'll take some examples. This rock, paper, scissors detection we will use for this particular session on day 3. We'll have a live coding session with PyTorch, which is another machine learning framework, and we will explain to you what the training pipeline is in machine learning. Another thing will happen on day 3, that is, we will give you the first assignment. That does not mean that you have to complete it by day 3. We will release it. We will tell you what needs to be done. And in subsequent weeks, we will give you the necessary ingredients or the necessary skills that you need to successfully complete this assignment. That will start from day 4 onwards. We will give you some more details in day 4 about the first assignment. And then we will have a live coding session using TensorFlow. Okay, so we will tell you how to structure a project, how to use concepts like transfer learning and data augmentation for training. We will use some object-oriented programming concepts to build the training pipeline. And then we will train the model, we'll build it, we'll train it, we'll test it, and we will do inference. Right? So these things we will cover on day 4. And we will conclude day 4 by introducing to you computer vision. Right? So this is another core focus of the course, because of course, if you want to detect a person, you need computer vision. So we'll tell you what are the major areas of computer vision, and we will introduce to you so that you are prepared to what is to come next in the course projects and in the assignments. Day 5, this will be the last day where we talk about machine learning in general. Right? So from day 2 to day 5, we will not worry about embedded systems. We will give you the background about machine learning and make you prepared so that you are able to develop a machine learning model properly. Right? That's the idea from day 2 to day 5. In day 5, we will talk about AI in the real world and some related concepts like ethics, bias, responsible AI. Because if you are deploying AI in the real world, which is our purpose when you learn the course, you need to know these things as well so that you are aware what to consider in real world applications. That brings us to our break. So on 15th October, we will not have any classes, because by this time you have learned about machine learning, and we hope that you can use the extra day to get yourself familiar with these areas. Starting day 6, we will look at the more embedded specific applications. Right? Now in day 2 until day 5, you develop machine learning models, but you mainly use the language Python. Right? But when you look at embedded systems, what happens is you use languages like C++. So therefore, on day 6, we will teach you the best practices in C++ programming for embedded applications. And then from this point onwards, we will slowly transition from general ML into tiny ML. So we will not take the jump immediately, of course, that will be very difficult, but we will go step by step. So that is covered in day 7 and day 8. In day 7, we will build and train a deep learning model so that we can deploy that in an edge device. And we will take a case study for that using a Jetson TX2 hardware device. So what we will do is we'll collect data, we'll train the model using some high performance resources, high performance computing resources. And once we train the model, we will deploy that in a Jetson device. So this Jetson is a single board computer. It has a microprocessor, which is more powerful than a typical microcontroller. So that is why I said we will slowly go from general ML to tiny ML. Tiny ML is microcontrollers, which do not have a lot of resources, but this one is in the middle. Okay, we'll do something similar in day 8 as well. So here what we will do is we will take data from your smartphone, mainly accelerometer data, and we will use this development platform called Edge Impulse. So we'll take data through the smartphone, we'll send it to Edge Impulse, and then we'll run the model, take some decisions, and we'll show you how these smartphones and these platforms can work together. Right? That is happening on day 8. So day 7 and day 8, we have dedicated that to the transition between general ML and tiny ML. Starting day 9, we will look at the tiny ML portion of things. Now you know how to develop machine learning models. You know what stands in the middle. Now let's look at the extreme edge cases. For that, in day 9 and day 10, we will introduce to you the capabilities and tell you how to program, how to configure this for machine learning workloads, both Arduino-based platforms and also the STM family of microcontrollers. Day 9, the first day of this discussion, we'll give you an overview of microcontrollers, and we will familiarize yourself with embedded hardware platforms at the edge. Right? Then in day 10, as I mentioned earlier, this Arduino is a very popular platform, but it does not work everywhere. It is not suitable always. So we will tell you some alternatives as well, which is what we are doing through the discussion of STM microcontrollers. So once you get familiarized with the Arduino-based platforms and STM-based embedded hardware and the software, that framework, then we will look at how to deploy these things on these hardware platforms. Day 11, we will introduce to you how to deploy embedded AI solutions. This is mainly using Arduino. Okay, you can see this is a gesture recognition algorithm. So this discussion will help you. This content will help you to successfully complete the assignments as well. That is the purpose. Right? So we will, of course, not tell you how to do the assignment, but we will give you the related materials like this. Okay, so under this day, we will give you a detailed explanation of the embedded AI pipeline. What are the optimization that we can make to get better performance through the model? And then on that day, we will give you the second part of the second assignment that is connected to gesture recognition. So it's a two-step process. The first assignment was also related to gesture recognition. You do part of it. And then as a second assignment, you do the other part. Okay. So in day 11, as I mentioned earlier, this is predominantly using the Arduino platform, Arduino-based platforms. In day 12, we will do the same thing using STM. So we introduced these two different types of microcontrollers in day 9 and day 10. In 11 and 12, we will teach you how to deploy machine learning in those two types of microcontrollers. Right? So day 12 is dedicated for STM. We will tell you how to deploy the gesture recognition using Cube AI. That is the framework that you use with STM microcontrollers. How to deploy that. We'll have a couple of case studies as well, and we'll teach you how to deploy. Now we have 4 days left, 13, 14, 15, 16. In those 4 days, we will work with you to complete these two projects. So when you learn the embedded AI training pipeline, you learn some of these things that helps you to complete these two projects. But in the last 4 days, we will work with you, we'll code with you, we'll develop the entire system with you that allows you to develop the wake word detection project, as well as the person detection project. Day 13 and 14, those two are dedicated to the wake word detection model. We'll tell you from end to end how to do that, starting from selection of the data set all the way to deploying that in this platform. 15 and 16, we will do the same thing with the person detection model. Okay, so we'll give you the complete picture of how to do the installations, how to test, how to run inference. Okay, so building, training, testing, and making predictions through machine learning inference. We'll cover the whole end-to-end spectrum throughout the 16 days. So when you cover this content, you will be familiar with a lot of tools that are commonly used in machine learning and embedded systems, starting from the Google Colab. Some of you might be already familiar with this. It's a cloud-based platform that allows you to run machine learning related code. It gives you resources to do that, cloud-based resources. And we will also make use of this TensorFlow playground. So in Dr. Sadeep's presentation, you saw how neural networks work, what they are. We looked at the forward pass, back propagation. This TensorFlow playground allows you to play around with different layers of neural networks and see how it affects your prediction. So we'll use this when we are giving you hands-on experience in the first few days, how to play around with machine learning applications and how to develop these models. Through the smartphone deployment, you'll be familiar with this Edge Impulse platform as well. And then we have Arduino and STM32 related infrastructure that you will get familiar as well through the two projects that we will complete. And because finally, the final tool, because you'll be dealing with embedded applications, you need embedded C++ programming. For that, we'll mainly use VS Code. This is a professional IDE used by many of the industries over there. So you'll be familiar with VS Code as well. Okay. So that is what you can expect for the remaining 16 days. Sorry, remaining 15 days, because today is day number 1. Okay. So feel free to send any questions you have on the chat. I'll be happy to answer those. While the questions come up, we'll have a dedicated Q&A session as well. Allow me to give you some remarks about the course in general. So this will be conducted in English. If you don't understand something, because language is a barrier, we will give you Sinhala and Tamil explanations as well. Every day, we will have time for questions and answers. Right? So we have divided these days among the panel of lecturers who specialize in those areas. And this is the team that will walk you through this content. We have Kitmin, Sahan, Senura, Abba, Iresh, Amaya, Kanchana, Tehara, and Visal, who will carry out bulk of the lecturing work. And these 3 people you already met today. And so we'll be overseeing the course and supervising the course throughout these 16 days. So we have actually spent a lot of time on developing this curriculum and the content for this. It is designed to be outcome oriented. As I told you earlier, we tell you what the objective is and we give you the skills required to achieve that objective. We do that by working on real world applications, right? So we teach you the fundamentals together with real world applications. We spent a lot of time on developing the curriculum, actually about 2 months, maybe even more than that, where we discussed among ourselves how exactly to deliver the course, what's the flow, what is the content for every day, what can be digested by a person who is new to the domain, what can we offer extra to the people who already have experience. So we want to cater to the entire spectrum. It's a tough job, but we'll see. We'll try our best. Okay, so the curriculum and the content, it's custom made for the course and taught by a highly qualified panel of lecturers, as you saw on the previous slide. So some of those individuals are not based in Sri Lanka. Kitmin is based in Canada. Abba is in California. Kanchana is in New York. And we have Amaya from Abu Dhabi. Yeah, so some of these people have migrated maybe last week or so. So maybe it's the case that Visal is now in Singapore. I'm not sure. Right? So they have agreed graciously to align with the time slots that are convenient for you. For example, I know for a fact that for Kitmin, it's around like 3 in the morning right now. So when conducting lectures, it will be the same time for him. So they have agreed, despite those time zone issues, to conduct the sessions that are convenient, conduct the sessions at a time that are convenient for them. Right. So you can see the qualifications of these people. They are well qualified to talk about the areas that they will present throughout the course. Okay, a few more remarks now that you know about the curriculum. So when you go through this and you complete the course, you will be eligible. You complete the course, you will be eligible for the course completion certificate, right? So to get this course completion certificate, you need to pass both assignments. Okay, we will not be taking attendance, which means that you can access the recorded lectures. I'll come to that. But to obtain the certificate, you must pass both assignments. For that, you need to acquire the knowledge. That knowledge acquisition can be done by taking part in the lectures, or if you miss it for some reason, because we know that we are doing this throughout 8 weeks, and it might be the case that you cannot attend each and every lecture, we will give you the recorded lectures. I will show you the platform that we will use in a while as well. So once you complete this, what can you do with what you learn? Of course, you can contribute with embedded systems or embedded AI solutions for your current workplace. Maybe you get a promotion with the new skills that you get. Maybe you can start developing your own product, right? And then you can pass your knowledge down onto more people. That is our purpose anyway. We need more and more people who have expertise in these areas so that we can have a productive workforce in these related areas as well. So to do all this, we'll be starting the next session from day 2 onwards, all the way to day 16. Day 2, the first day, as I mentioned earlier, this is a free session. Anybody can come. But from day 2 onwards, only the paid applicants can join. So we have sent you instructions via email. We have set the payment deadline to next Wednesday. So please make sure if you decide to continue in the course, you complete the payment by this date. The payment instructions, they are available on the course website. So let me quickly show you the course website so that you can, for those who did not notice the course website, the instructions, sorry, not the course website. I'm pretty sure you saw that. But if you did not see the instructions, let me show you where to find them. So this is the course website. You can go here and you press this button. This is a copy of the email that we sent, right? So you can see the payment options are listed here. And what you need to do is once you make the payment, there is a Google form. Please submit the Google form, including your payment confirmation slip. Otherwise, we cannot track where money came from. So to do that, please submit the Google form once you complete the payment. And we have done a similar course in the past. And one thing that we noticed is that people use ATM fund transfer machines. The issue with that is, again, it is difficult for us to track the transaction. So please fill a deposit slip and then deposit if you're doing it in person. If not, you're doing an online transaction, then you can take the digital receipt and upload the digital receipt. Okay. So I hope the payment process is clear to you. That is what we expect. If you are continuing beyond the second date, you need to complete that by coming Wednesday, by 28th of September, right? So please follow the instructions properly. Otherwise, it will be very difficult for us and also the people who are administering the course, the finance division and the course assistants, to figure out who got registered and who did not. So it's not very complex. You just have to follow a simple set of instructions. Okay, right. Another piece of important information. So when I was telling you the projects, I showed you the hardware platform that we will be using. So now you might be thinking, do we need hardware? Do I need to get that TinyML learning kit? Well, not necessarily, right? All the assignments, they are designed so that you can do them without the hardware. You can learn the materials and earn the certificate without hardware. But if you want to deploy your system in the hardware and see it working for real, because without hardware, you don't have a microphone, you don't have a camera for the person detection, right? So you cannot deploy that in a microcontroller. The assignments you can complete where you develop the model and make it ready to be deployed, but to actually deploy, you need the hardware. So for that, we have two options. One, you can purchase the hardware, and for that, we have given you a Google form. The reason why we are doing this is it is beneficial for you if we gather all the people who want to order the hardware and then place one order. So then you don't have to pay extra shipping, right? So we'll help you with that process. If you take that option, you have to fill another Google form and tell us that you need the hardware. That instruction also is available on the same document that I showed you together with the payment information. So you can go to that, get the link to the hardware request form and fill it. That's one option. And the second option is we have purchased some of these machine learning kits. We actually have about 6 of them. We will make them available through the university. So we'll give you more details as we progress through the other days. For those who do not intend to purchase the hardware and keep it for themselves, you can come to the university. We will tell you what dates. We'll find dates that are applicable to most people who want to come to the university. We will make them available through the laboratories. So then you can come, you can work on that full day, but you cannot take the hardware devices home with you. You have to leave them in the lab. Okay. So those are the two options available to you. You can either purchase, keep it for yourself, but if you can't do that for any reason, we will make them available. And even if you are not a student at University of Moratuwa, we will get permission for you to come to the university, come to the lab and use the hardware kits that we already have. So we have about 6. If we get a lot of requests, you will have to work in groups or find alternative time slots. So we will work around that depending on the responses we get for this Google form. Right. So I hope you're clear about the payments and also about the hardware requirement. I mentioned this already about the eligibility criteria for the certificate. You have to pass both assignments that you can do without hardware. Attendance will not be compulsory. It is good. We highly encourage you coming to the live sessions because then you can ask questions, right? Every day we will allocate time for Q&A. You can ask questions from that day or maybe from a previous week that you're not clear about. Okay, so interaction is vital for you to understand these things. But for some reason you miss a class, we will make the course material available through an online platform, and that is Moodle. So let me quickly take you to that as well. So this is the Moodle page of a course that we did earlier. This we did last year. This is microcontroller-based system design. This is a more embedded systems related course. It has nothing to do with machine learning. This particular course is a more advanced version of this, where we talk about deploying machine learning on embedded systems. So now you can see here the assignment submissions were taken through the Moodle page, and the recorded videos were shared like this, including the slides. Right? So this is the online platform. We will make the recorded lectures available through this. So if you miss a class for some reason, you know where to look. This access. So even if you are not a University of Moratuwa student, we will provide you with the access for all the people who pay and register. We will give you the access to the platform so that you can watch the recorded videos and other relevant material as well, because we will be uploading any reading materials for you, anything we will handle through the platform. Coming back to the slides. For communication, we are going to use email and WhatsApp. So again, for those who pay and register, we'll prepare a WhatsApp group, and any quick communication, we'll send it through that, and we'll keep you posted through emails as well. Please check the course website, the one that I showed you earlier. All the details we will make available. There is one small discrepancy that I noticed because we made this decision at the last minute. When you see the class schedule, you can see 9th October in this particular website, it says no class, but we have actually decided to shift it so that we can have this nice breakdown between general ML and embedded ML. So therefore, 15th October, we will update the website. 15th October, you will not have classes. On 9th, you will have classes. Right? So we'll keep the web page updated frequently. And immediately after this session, we will upload the recorded video of this session as well, also online, so that anybody who missed taking part, they can refer to the video and get the instructions. Okay, so that's it, folks. That's all the information that I wanted to share with you. We will allocate some time for Q&A so that you can clarify any doubts that you have. I can see my chat showing some notifications as well. We can check on Slido to see whether we got any questions. Yeah, so any questions, feel free to unmute and speak, or else you can drop a message in the chat on Zoom, or else you can use Slido. This is the QR code that you need to scan. I'm pretty sure you are very familiar with QR codes now, or else you can go to slido.com, type in this pin, and then you can go to the Slido platform, ask your questions. Okay, we have one question through the chat. Can we engage in any type of project work? I think we covered that already. Okay. Do we have any questions? Let me go to Slido as well. Right. So Kitmin has been answering the Slido questions while the session was going on. Let's see if there are any unanswered questions or questions that can benefit all of you here. Start from the top. Kitmin, do you want to highlight anything, or we'll just go through the list? Okay, there's a question in the chat. So question in the chat, can anyone register again before the course start? Pawan, if that is the case, please ask the person to send an email to the course email address that we have given here. Yeah, it's, let me send that to everyone. It's sc-entc@uom.lk. That's one option, or else you can drop a message to Mr. Damit through this WhatsApp number. And so we'll evaluate the situation, and we'll, yeah, please ask the person to send in the registration request. We'll evaluate that, and we'll see how we can grant permission. Okay. Going back to Slido, do we have anything else? Kitmin?
Can you hear me?
Yeah, we can.
Okay. I think I've answered all the questions. We can allow like participants to unmute in the security settings. I think we'll have to update that.
Okay. Okay. Now the sun is getting through my window, so my video looks weird. Anyway, let me enable unmuting. Give me 1 second.
Right.
Dr. Charles, I ask a simple question. What is the Python and C++ knowledge that you require from the participants?
So it's good if you have some basic background, but even if not, we don't assume that you have any knowledge and then we'll teach you from the scratch. But for that, you will need to do some homework of your own as well. Like within the week, we'll tell you where to look. And within that week, you will need to do some homework, because otherwise we'll be lagging behind with those who are familiar with these programming languages anyway.
And also the students' question about projects was, are they allowed to do any other project than what you have prescribed?
The 2 assignments are quite specific, Dr. Ranga. So they to get the certificate, they need to complete.
Yes, otherwise evaluating will be a big problem, right? Because we have to look at multiple aspects.
Yes, because then the projects will have different complexities. It'll be difficult to judge whether the person got the required knowledge to be eligible for the certificate. So they can, of course, work on their own projects after the course. That's the whole purpose. But for this particular course, the 2 assignments are specific. You need to complete those.
Yes, after the course, if the students are willing to engage with any other project or they need our support in securing employment advancements and so on, will there be a support network available for them?
Yeah, so we'll create the WhatsApp group. Through that, we'll keep them connected. We are actually working actively on some industry collaborations as well, and we will keep the industry informed about the progress of the students. So not to promise anything, but that is on the cards. Yes.
I think we also have some industry participation as well in this course.
I think there's a question in the chat asking a ballpark figure for the TinyML kit. Yeah, I had that on the slide. Let me quickly go to that. Okay. There it is. So this is a screenshot from this particular website, and they have priced it for 83 Singapore dollars. So that's a rough estimate. This does not include shipping and taxes. So yeah, depending on the number of people who would like to buy this platform, we'll have to figure out a way. So in LKR, that's about 20 to 25,000 rupees. Okay, do we have any other questions? Anything that you're not clear about? So if you go to Slido, you will be able to see all the questions answered by Kitmin already. Kitmin, anything that we should highlight, something that you think is important for everyone?
There's a particular question asking whether ESP32 hardware with sensor add-ons can be used for this course project. So something that we investigated was using low-cost like alternative hardwares instead of the little kind of expensive platform that we're using, the Arduino BLE Sense. What we experienced was it's a bit difficult getting these machine learning algorithms on other hardware like supported in a very easy to understand manner, because we want to make it as easy as possible for everyone to understand. So the best platform was Arduino, but we can try it on other platforms such as the ESP32 that this person has suggested, but there's no guarantee yet since we haven't tested that. The reason we stick to TinyML using Arduino Nano Sense is because that's the most supported platform right now, and we want to make sure that you all have access to the most supported and the one that's easiest to work with, so that the purpose is to help you all solve like real world problems easily. So that's one thing I can clarify. Then one other question, like how many hours should we dedicate for this course, and specifically like these assignments? Assignments, I think we can give like 2 to 3 weeks of time to like complete. And also hours wise, since you don't take attendance, I assume you have time to go through the videos on your own scale, on your own base, easy like time scale. But then I guess to make sure that you stay in touch with the content, at least 5 to 6 hours per week would be a good time to dedicate, so that you're on top of what we're doing and you are able to like complete assignments on time. But it's more like we've given you the freedom and flexibility to work in a way that's easier for you all.
Thank you, Kitwin. A couple of questions on Slido that I just noticed. How can university students join the course? We've actually given you all the instructions on the course web page. So let me go to that again if you did not notice. This is the course web page. We have given you the link to this on the slides as well. We'll in the text messages and the emails that you received telling you the course is happening and visit this website, this link is given. So you can easily access this, and then you have to go here, visit instructions for next steps. And when you go there, you can see all the options, what happens, the policy for students and for everybody else, all the details are here. So please refer to this, and then you can get that relevant information. Another question, can ENTC students? Well, yes, we have sent you separate instructions for ENTC students because this is conducted by the department. So for those students, we have sent you instructions. Please refer to that. It was communicated to all the batches. You should have that information already. Another question, the 2 assignments need to be completed within the 16-week time frame, or additional time is given after the course is completed. Well, when we were talking about the schedule, assignment 1 is given on day 3 itself, so that you have time to learn those things and apply. We will give you enough time, more than enough time actually. And if there are any special requests, we will accommodate them as well. So we don't have a hard and fast rule saying that the assignments have to be completed within the 16 days. Based on your learning experience, we will set the deadlines accordingly. Question, what are the softwares that we need to pre-install prior to the course? Do you provide licensed versions? Kitmin, please add to this. We will use cloud-based platforms mainly. Colab is a free tool. You can use that. Yes.
We will also be sending the list of required softwares for like the registered participants and how to like install those things via the next email. So yeah, it's mainly open source.
So you can expect all the registered those who pay and register, all of you can expect to receive further instructions after the payment deadline date so that you can install what is required. We'll send you the instructions. Okay, anything else?
Yeah, this question about whether you can get in touch with instructors about clarifying your own projects. I think so. You have access to our emails, and you can get in touch with us. I think definitely we are there to like help the registered participants and the course attendees get through any problems. So you can clarify doubts during the course. Yes.
Okay. There's a question about whether there are discounts for University of Morocco students. Well, as I mentioned earlier, sorry, there was some noise. As I mentioned earlier, there was some instructions sent to ENTC students, but for anyone to get the course completion certificate and to access the recorded materials, meaning in other words, to get access to Moodle, they have to follow either one of those 2 payment options. So we have given 2 options, one for students and one for others, to get access to the recorded lecture materials and also to get the certificate. The only 2 options are those 2. It's what we have advertised on the course web page. Okay. I think my answer to Dr. Ranga's question about Python and C++ knowledge, I don't think that was very comprehensive. So if you have a background, that will definitely help. in the same email that we send you what softwares you need to do for all the paid participants, we will send you resources to get yourself prepared as well. And then you can clarify the doubts during the lectures and you can keep up to speed, right? So for those who do not have any programming background, you will have to do some extra work in between the weeks to get familiar, right? Because if you don't even know the syntax, then that's an issue. Okay, so that we cannot teach you in the course. So that is why we assume that you have knowledge from some programming language or the other. We'll send you the resources. So of course you can self-learn and then clarify the doubts later on. But that's important to keep in mind because we have different people with different capabilities in this audience. So we have to make sure that people don't get frustrated if we just keep on telling things that they already know. That's a problem also, right? So we have to strike the balance. We'll send you the resources accordingly. So looks like
there are no questions. Yeah.
Yeah. Did you get anything as a direct message, Kitmin? No, not.
No, nothing. I think everyone was asking about whether this recording will be shared. So we'll email it to all the registered participants.
Yes, the recording. This recording will be made available on the course webpage. You can expect to see that latest by around noon tomorrow, so that you can tell your friends if somebody could not come. You can check the web page. We will also send out an email saying that the video is not now available, so that anybody can come and refer to this. We did not record the keynote session due to request from the speaker and the speaker's employer, so which is why we post recording at that time. But the information related to the course is, of course, we are recording right now, so it will be made available. Right, so if we don't have any questions, I think we can wrap it up. We took about 2 hours and 40 minutes. We said between 2 and 3 hours, so we are on time. So we got a participation of more than 100 people. I was looking at the number and then it remained between 100 and 110 for a while, but right now most people have left because they got the information. So it's great to see all of you here. We are actually delighted by the enthusiasm that we got for the course. When we initially started designing this, we did not expect that much responses. Then we had to extend the deadline as well to allow more people to register. But yeah, so we are delighted by the number of people who turned out today. And we hope to see you from day 2 onwards as well. So our plans, as we mentioned earlier, our motivation, we'll be doing similar courses in the future with different topics. Of course, not this one. We'll have another intake for the same course maybe sometime in the future. We don't know yet, but we are prioritizing some other technical areas as well, like processor design, for example. So that you can expect to see promotional materials for a course like that towards the end of this year. So we want to make sure that you get the skills that are required in the industry. That was our idea. So to go to this inverted style of teaching where you work on the projects and you learn the concepts while working on the projects. We found that to be a quite exciting way of learning things, because then you know, you can see and feel what you're working on. So that is our whole purpose. And we'll be doing more courses like this in the future on different technical areas. So we expect to see you on those as well. But for now, our focus is on this, the embedded machine learning course. So we expect to see all of you from day 2 onwards. Well, not all of you, that doesn't happen, most of you. And so those who decided that you would like to continue, we hope to see you in day 2. So thank you again for joining on a Saturday afternoon. I wish you to have a good rest of your weekend and a good week ahead. And we'll see you next Saturday. Thank you.
Thank you, everyone. Have a pleasant weekend.
Thank you. Thank you, Dr. Ranga and Dr. Subodha.